to multiply two polynomials together, things sometimes get a little bit messy. With that in mind, let's look first at what happens when we multiply two binomials, so two polynomials with two terms each. Let's suppose we want to multiply the binomials x plus y times 2a minus b. Again, this is a job for the distributive property. We can think of x plus y as a single, fairly complicated object, and we want to distribute it across this subtraction. So we'll have x plus y times 2a minus x plus y times b. Right, this is just the distributive property. But now we can use the distributive property again. Using the distributive property here, we'll have x times 2a plus y times 2a. This minus is this minus. X times b plus y times b. I told you this got a little bit messy. Let's do this multiplication. I'll write this as 2ax plus 2ay. We'll write this as plus the negative. Negative xb minus yb. And now finally we'll do the addition, noticing that there are no like terms here. So this appears to be the result of the multiplication. And notice, when I multiplied one binomial by another binomial, I got 1, 2, 3, 4 terms in my result. Of course, I would have had fewer if I'd been able to combine like terms. What are these? Well, 2ax was 2a times x. 2ay, that's 2a times y. Negative xb, that's x times negative b. Negative yb, that's y times negative b. What did we need to do here? In order to do this multiplication, we had to multiply every term from the first binomial by every term from the second binomial. Now, there is an acronym that provides us a way to keep track of those pairs when we're just dealing with two binomials. We will first multiply the first term from either binomial. Then we will multiply the outer pair. So the first term from the first by the second term from the second. Third, we'll multiply the inner pair. So the second term from the first by the first term from the second. And finally, we'll multiply the last pair. So the second terms from each binomial. And you see that this catches every possible pair. However, notice that this only works for two binomials, right? If one of these were a trinomial, there would be a middle term that we never use. This method, multiplying in this order, is sometimes referred to as the FOIL method. People sometimes use this as a verb, FOIL it out. Please don't use this as a verb. It's already an acronym. It's not a verb. But what is this really? This is just using the distributive property twice so that we multiply every pair of terms. It is, however, a nice shortcut, considering that we're going to be multiplying pairs of binomials fairly frequently. So I'd like you to give this method a try. Multiply the binomials x squared minus 4 times x plus 2 using this method. Pause the video and try this now. Multiplying our first terms, I'll have x squared times x. Multiplying my outer terms, I'll have x squared times positive 2. Multiplying my inner terms, I'll have negative 4 times x. And multiplying my last terms, I'll have negative 4 times positive 2. So simplifying, x squared times x is x cubed. X squared times 2 is just 2x squared. Negative 4 times x is just negative 4x. Negative 4 times 2 is negative 8. So noticing that there are no like terms here, my product is x cubed plus 2x squared minus 4x minus 8.